For this first one, let's look at JavaScript. And again, this is kind of just how everybody does variables or declarations. And in JavaScript, if you've written more than a line of JavaScript, you've done this at some point. You've done var I equals 1 and semicolon, and then if we log that, we will get 1. Yep, easy peasy. And JavaScript is so chill and relaxed and wild, wild west that you can even remove the var, and if I rerun it, it will have no problem with that. Now, this is ES5 and before, so everything before 2015, this is the only way to declare a variable was with var, and you could get away without even declaring it. Like Python and like Ruby, it's a dynamic language. There's no formal declaration. You can do it for a variety of reasons, but you don't have to. A way to try and bring some order in was to do the use strict rule, which now if I run the program, we get a reference error here on line 2 because, well, I didn't declare I. It's really helpful, and it's baked into a lot of frameworks and stuff. Okay, there's nothing intrinsically wrong with this. This is called duck typing. It's a way that lots of languages handle their variables. They're assigned dynamically by the interpreter, the compiler, whatever, and JavaScript follows that. Python is a very similar case. We do I equals 2 and print I. It will work just fine. There's no formal declaration. We don't have to do something like this, int I equals 2. It has no idea what we're talking about. And in fact, I don't even think there is a way in Python other than doing something like that. You can't even declare a variable in Python. You simply initialize it, and Python takes care of the rest. Ruby will be similar. We just simply do I equals 2, and then below we can put I. There's nothing fancy to do. There's no worrying about declaring data types or anything like that. Now, C is a tiny bit different. If we come over to C and we take a look quick, we've got our main function. Don't worry about this stuff. This has to be here. This is just the main program, and then this is the code that will actually run, and just good practice to return something to every function. If I nuke this, I can do I equals 1, and then we'll drop in here a printf. We'll give it a value of I, and then in C we have to tell C what data type the element is. It's a digit, and then we want to create a new line, and we'll drop I in here. Now, this is not okay in C because on line 3 it says I is undeclared. It's not even you can't just use it because C won't dynamically declare it. So we have to put int I here in order for it to work. And I forgot a semicolon here because I've been writing JavaScript too long, and there we go. So C demands this. Java does as well. C# does as well. PHP is a dynamically typed language. You don't have to do anything. You just say I equals 1, and then we can print $I. Done. There's no data types to worry about it. So we can maybe talk about this a little bit more later. The advantages and disadvantages of a heavily typed language. TypeScript has become very popular for that reason because it tries to bring some order into the JavaScript data types. It's not a priority right now. Here we are. This is how you have declared a variable in JavaScript. You don't have to use var. You can just simply say I. But what's important to note is that JavaScript only has, to this point in ES5 up till 2014 before ES6, only has a scope for function, or a function scope. And what that means is a variable is known in its own function and nowhere else. You can't break it down any farther than that. Python is the same way. Now, JavaScript by default uses the global scope. So this is automatically a global variable. Everybody in the whole script can see it. And again, if you're talking about small scripts of 20 lines in 1995 or a few hundred lines in 1999 or 2000, that's no problem. But we are now not to the point where we're writing thousands of lines, but thousands of files. This can become a problem, and it's a problem. Maybe you're thinking, wait a minute, aren't other languages this way? Yes, they are. JavaScript will become apparent in why it's a little bit strange. One of the best ways to to get this across, the difference between block and function scope is with for loops. So you may think for loops are out of style, but they are, in fact, I think the fastest way to actually loop over something, whatever you might have heard. In Golang, it's actually the only type of loop that there is. So I've written out a loop for loop in JavaScript. Congratulate me! How awesome am I? We're going to use for loops again later for iterators to kind of in the generator section to go over how iterators work. But we've declared a variable, our incrementer. This is our condition, and we increment this at the end of every code block. And whenever it's not true, we will exit the code block. So I'm going to remove these two for a moment, and I'm going to go ahead and run the code. And this is what happens, 0 through 10. This is the actual loop, of course, and then 10, I can drop in here, value after loop. And the value after the loop is 10. So I is still accessible, so if you for some reason needed to use I again, it would still be set. Now, if we go over to Python, and we'll take a quick look at how to write a for loop in Python. This should be really fast. We'll do, over here, we'll do for I in range, and we'll pass it 0, 10. Remember, range is inclusive of the first number, exclusive of the second number. So we won't get 10 no matter what happens. It will stop before it gets there. And for all that, I is, and then we'll drop I in. So this is going to run from 0 to 10. It's going to print off I each time through. Python's an indented language, so this is outside of the loop, and it will print I at the very end, and the value is the same as what it was at the end of the loop. Again, it's inclusive of the first number, so 0 gets included. 10 does not, so I is never incremented to 10. And we don't have the option of putting var in here or int in here, anything like that. So Python works exactly the same way that JavaScript does, and I don't think there's a way to get around this. Now we've got a couple of alternatives here. Okay, now we'll go to C, and I am going to get rid of this. Another way, if you're wondering, you can also do something like that. You can declare it on one line in C, like we do in JavaScript, or var I equals 1. You can put int I equals 1. But let's write a for loop in C to kind of get a vibe for how it works. So we can get rid of this, and we'll put for int I equals 0 while I is less than 10, I plus plus, and then we will grab this print statement and put it inside. So I'm going to run the code. The compiler, it works exactly the same way JavaScript does. Hopefully you're encouraged, because this is identical to what we had on the last in the JavaScript section. The only difference is when you're printing to the terminal, it's a little bit uglier than JavaScript. And we used var over here as opposed to int over here. Now, here is the tricky part. I'm going to take this, and I'm going to copy it down here. So this is the same as what we had in JavaScript and in Python, where we print each section through the loop, and then we print it off at the end. That's what we're going to do now, is we've got the for loop, and then we're going to print it off at the end. So I've run it, and the compiler's not okay with that. It says that I is undeclared on line 7. You're trying to get me to print off I, and I have no idea what you're talking about. That is because this is not function scope. This is a block scope, meaning it starts, the variable lives as long as the brackets do. So we have int I right here. Now, this is the part where it gets tricky. If I pull the int off of here, and I come up top, and I'll declare it as int I equals 0, we'll declare it here, and I run it, it will work now because the I that it's using the whole time is this I. And it's a block variable, which in this case the block is the whole function. So we can keep I going if we want to. If we don't want to, we can get rid of this line, and we can put int in here, and I will go away. Well, now this obviously breaks it. What we can do yet is declare I out here. That is a function scoped variable. we can declare I in here. That is now a block variable that's no bigger than the for loop. And then we can print off I. That will print off this I. So when I run it, we get 0 through 9, and then we get the initial I right here. So this is the C way of doing things. You have a lot more flexibility because it only uses the block. Wherever the variable is defined, it's good for those brackets. This is not a C class, so I'm not giving you absolutely every bit of information, but you get the idea. In Java, it will work the exact same way. If I come over and write a for loop, and again, I hope this is encouraging, because if we do I equals 0 while I is less than 10, I plus plus, and I'm going to steal this line and drop it in here, and we'll change it from printing off hello world to, how about, the value of I is, and we'll concatenate at the end I. So this is a Java loop, and the compiler, I don't know, always seems to take a second. I mean, it's a little bit ugly formatting, but it works just the way we expect it to. If I copy this and I put at the end, just like C, it's going to break. The value after the loop, the compiler's not going to be okay with this, because we declare the variable inside of our for loop, and it says, hey, I don't know what you're talking about. That variable does not exist. Exactly like C. If I pull this int off here and put it up top and initialize I at 0, it will work, and it will give us 10 at the end, because we're using this I to print out down here, and we're incrementing this I through the loop, and we're printing off that same I down here. Okay, so this is where it's going to get a little bit tricky. If we try and drop int inside here to get ourselves a block level variable, Java will break. Unlike C, it says the variable I is already defined in the method. You can't reuse it. So if I get rid of, we can't have a function scope and a block scope in the same function. You got to pick. So we can do that, and if I run it, I is only defined one time inside of this function. Means we can't use it outside of the block, or I have to get rid of the int here. So we have a little bit different flexibility. C, you can declare a variable as many times as you want, and it will get tossed at the end of the block. With Java, you have to choose the block that you're going to use, but again, hopefully you get the idea. Okay, so let's come over to Ruby. Ruby's a little bit like C and Java in that it won't allow us outside. So let's do real quick. We'll go from 1 to 10, dot each, do I, and then we will put I on the screen, and we will end our function. Now this is just a plain Jane. I made an array of 10 elements. I looped through, and we get all 10. If after the end I try and put I, Ruby doesn't know what I'm talking about. This I doesn't exist. So hopefully you're getting the idea here. This is a block level variable. I is. There's lots of ways to write loops in Ruby. We could do 3 dot times do I, and then we can put I. Whoops. We can put all kinds of typos. We can put I there, and it does the same thing. The only way around this, if we try up here and initialize I at 10, it will print off 10. So this is a little bit more like the C way. We have a block level variable. We have a more global, or a function scope variable. This is the block. It ends with the block, and this is the function scoped variable. Okay? So, real quick review. JavaScript is the weirdo, and we'll get to that in a second. PHP, we didn't do PHP. Let me just paste one in here. I'll grab one that I already had written, and we'll run it. And there's no way to declare the variables because they're dynamically created, just like Python. It's just I already exists. I still exists at the end. It's a function scoped variable. Python function scoped variable. I will be available for the whole life of the function. I will be available for the whole life of the function. In C, you can make a block level variable here. You can make another block level variable here, or you can use just one variable here and reuse it, etc. Okay? In Java, you can make a block level variable, but you can't remake it outside. And then in Ruby, like C, you can make a block level variable. You can make a new block level variable that will end and then use the main function block variable. Okay? So there's a bunch of different examples. Hopefully you're still with me. We've come back to JavaScript. This is why JavaScript is confusing to developers. We have var I in here, and come back up here and do var I equals, let's say, 2. Let's do it something a little bit more crazy. Var I equals 20. This is the way we've got it in C. We've got int I equals 0, and we've got an int inside there. Here we've got a var I equals 20, and then we've got another var here. If I run the code, nothing changes. The value after the loop is still 10. All right, Java won't let you do this. C will, but C would print off 20. Ruby would, but Ruby would print off 20. And this is kind of a makeshift way, I guess, of how Python and PHP would do it. The issue, though, is that if I, up at the top here, let's say we just did var I, and I were to console.log I, you get probably what you expect. I exists, but it isn't actually set. Here's maybe the confusing part, is if I delete that declaration and I try and console.log I, well, if I come back over to Python, and before I exists here, let's print off I. Okay, it's not defined. You can't do that. That makes no sense. If we come over to PHP, and before the loop, I try and print off $I. PHP, the code still ran, but it says, I don't know what you're talking about. That variable doesn't exist. Okay, so you'd expect if JavaScript's going to act like Python and PHP, for it to act like Python and PHP, and we'll get an error. We don't. We still get undefined, okay? And this is called hoisting. What JavaScript does, okay, and again, we've got a weird blend of C, Java, Ruby type stuff and Python, PHP type stuff. What JavaScript does is it goes looking in any function ever, for the word var, and if it finds the word var, JavaScript will say, oh, there's a variable that's local to this function, in this case the global function. Let me grab it, and I'm going to put it up at the very, very top of the program. Okay, so it exists now. Hooray. I can get rid of this var now, and I won't be confused later. That is what you really wrote. So that when it gets to line 4, instead of saying I doesn't exist, it does exist, because JavaScript created it at the top of the scope. And then it used that throughout the program. Okay? Again, this is confusing. We've got C and Ruby do it the same way. Java does it mostly the same way. And you got PHP and Python doing it the other way. JavaScript is kind of a weird combination of both. And this just unfortunately creates confusion. I'll write a function here real quick so that you can see it maybe in another fashion. If we let's make a function here called getSum, and we'll bring in A and B, and we'll console.log sum in here, and up at the top we will set up a variable called sum, and we'll set it to 0. All right, and I will call getSum, and we should very much expect to see, should very much expect to see 0 get printed out, and it does. All right, this is the first line that gets run, sum equals 0. It calls this function. It prints off the global variable. All right, if we leave that there, and then we come down a little bit, and we set sum equal to A plus B, and then at the end we console.log sum. Sum right here will still be 0, because, or at least we're expecting it to be, because that's the global that we're using. Sum will get updated to whatever we pass it, so let's pass it 2 and 2. And then down here, when it logs, this variable will have changed because we changed it inside the function, and it will log 4. So we get 0 the first time, and we get 4 the second time. Again, 0 gets set, we call the function, we log this variable, we change this variable, and then we print off this variable. Okay? Now, if I put the word var in front of this, it's going to be totally different. When I run it, instead of 0 and 4, we're going to get undefined and 0. And the reason is hoisting, because JavaScript sees this and says, oh, okay, got it. Here's actually what JavaScript is going to do. It's going to say, I'm going to put this at the very top for you, and I'm going to get rid of that. I just hoisted your sum to the very top. Let me go look, and oh, here's a function, and here's a var inside the function. I'm going to grab sum, and I'm going to put it at the top, and now I can get rid of this. So, I declared sum, I set sum, I called this function, I declared sum, I logged it. Right now, sum happens to be undefined because I just declared it, and now I'm going to update that, and then I'm going to leave the function, and I'm going to log sum. What sum? The global scope sum, which is still 0. Okay? Hoisting is actually not very confusing. Just don't use the same variables over and over. But you might not be able to. You might not have a choice. You might be in a code base of thousands of files. Or you might have a joker developer on your team who is not paying attention, or that's how he's always done things, or he's used to overloading or overriding in other languages, and he's used to Java or C and Ruby, and this just is not okay. Well, having gone through a couple different examples here of how variables are declared, how they work, how they're scoped in JavaScript, we'll go back to the for loop, and we will, let me undo here. We'll go back to our for loop. Actually, it's just not hard enough to write a for loop in JavaScript. We'll do for var I equals 0. I is less than 10, I plus plus, and we'll console.log I again, and then we'll console.log I at the end. Man, look at that. I've written 2 JavaScript for loops in less than a half hour. This is what we were at the beginning. This is the confusing part, because var is getting stuck up here, and it's reusing that because of hoisting. We have a new option, and the new option is let. If we use let, this will now behave the same way that that C and Ruby does in Java, sort of. Let is now a block variable. It's no longer a function variable. It no longer gets hoisted. It's not going to print out 10. It's going to freak out because I is not defined. I only lives as long as the block does. If I put a var I back up at the top, it will use, actually let's change it to 1,000 so it's a little less confusing. That's the I that it's printing off over here. That's the one, the I is 1,000 because I'm outside of the loop when I run. This is inside of the loop. I've got a block variable. This when the I goes away. Now here's a decision that you can make, and it's probably best to just commit one way or the other. There's more and more move to just eliminate var, except in the very rare case that you actually need it. I still use it, but I've been using it for 20 years, so it's a hard habit to break. I'll try and going forward use let and avoid using var. But if I do let I equals 1,000, we will get the same behavior, thankfully, for a change, because this is a scope variable. This is a block level variable, and the block at this point, just like over here with C, is the entire function. Right? I is declared up here. I is printed off down here. I is declared up here. It will go away at the end of the block, and it goes away, but it still exists up till the end of the block. As a quicker way to show this, let's just make a function called main, so it looks exactly like our Java and our C, and we'll call main, and this will be just fine. Main gets called. let I equals 1000. That creates a block level variable that's good for the whole block. This creates a new block level variable here, and let I, it lasts for here. This one goes away. It goes back to the main one, or to the function one, and then the loop exits. So let is probably the new var. You just have, and the reason it exists is because there's confusion hopping from language to language about how things are actually supposed to work. The variable will exist even though you don't think it should, because it wouldn't in Python, or the variable should be blocked like it is in C, but it's not, so on and so on and so on. So this will allow you to avoid all the crazy havoc. Okay? So this is a big win. Now, the other win here, instead of always using let, so let is one of your bullets now. So var becomes let. We've got one bullet in let. The other bullet is going to be const. Okay, and you've probably seen const, but this is the other way to write variables. And const is the one that you should try and always use unless there's a reason for the variable to change. Okay, that's why var is sticky and tricky, because there are times when something shouldn't be changeable, and it is, again, in large code bases. That's very common, unfortunately, is for you to change stuff that you don't actually mean to. So how does constant work? Well, just like in C, and we'll look at it here in a second, if I make I a constant, I put, instead of var or let, I do const I equals 2, I console.log I, and right below it, I'm going to try and set I to 3, and JavaScript is going to get mad. That's a syntax error. You can't assign I after you already told me it's a constant. Okay? Very, very simple. Very, very straightforward. This is awesome. Again, as state becomes more and more of an issue, and state testing becomes more and more of an issue, constant can do a good job of protecting you. Now, we'll come back here in a second because we're not quite finished. Let's hop back over to C here, and let me get rid of all this stuff. If you wanted to make a constant, you could make constant I equals, we still have to do int equals, we'll do 5 here. And let me go back. I don't want to type out the print statement. I'll just LoJack this one. So we have declared I right here, and we've also told C that it's a constant. So if I run this code, no problem. If right below here I try and do I equals 4, of course we get the exact same error. You gave me this is a read-only variable. You cannot change it. Okay, so this is exactly what you would expect. All right, we haven't gotten to do anything in C# yet, so let's do C# real quick. It will work the same way. Don't worry about using system, same thing as C, it's just a header that needs to be there. We've got our class, and this is actually the way that Java works too. At the very top, before we run the main program, we can do public const int. Common syntax is that constants usually are all uppercase. Now, they don't have to be. In Ruby, and I can show that as an example, but if we set it equal to, let's say, 100, down below here, instead of console.log or console.writing hello world, let's write off number, and this should print off 100 to our screen. And it does if right below here I try and override number to the number 1. It will get mad and say the left-hand side of an assignment must be a variable. It's not a variable. You told me up here that it was a constant. Okay, so that is real quick a C# demo. You cannot change a something. It's using the const word just like everything else does. Now, in Ruby, this is not a fail, but Ruby just doesn't handle it that way. Anytime you have a variable that starts with an uppercase, so I'm going to do number equals 2, and then I'm going to put number, and we shouldn't have any issues. Semicolons from C and C#. There we go. We get 2. Now down below, if I try and overwrite number and change it to 3, and then I'll try and put number down here, Ruby will warn me, but it won't actually stop me. It says you've already initialized a constant because it's an uppercase N, and then it goes on warning, previous definition of number was here, and then it drops in 3. So Ruby will allow you to change it. It will just warn you that you did change it. C won't allow you to do anything. Java and C# won't. And now with constant, you'll actually get a crash. Okay. Now here's the last catch, the last gotcha, and then we'll wrap up this section. We have a constant here that's assigned to a very, very simple data type, a number. You can't get any simpler than that. Constant is actually probably the wrong name for these types of situations, just like it is in Ruby. They're not really constants. It's a constant in JavaScript, but only in the sense that it cannot be binded again. The variable can change, but you can't bind that variable name to something else. I will give you a very, very good example here. If we make a constant, and I'm going to call it my array, and we're going to do 1, 2, 3, 4, I'm going to console.log my array. Okay, and you should expect the array to pop up over here, 1, 2, 3, 4, exactly like it does. Now, what we have done here with this equal sign is bound this variable to this entity, this object. It happens to be an array. We cannot assign this to anything else, right? You can't bind it to something else. If I come down and say my array equals 1, 2, 3, 4, 5 and try and run it, it won't let us. You can't make a new assignment. You can't bind it to something new. What we can do is change the variable by pushing 5 onto the end. And if I print it off, it will let me push. Again, we didn't bind it to a new variable. My array is still pointing at a something. We're not changing the binding here. We're writing the variable, or we're changing the variable, not what the variable is bound to. I don't know of a better way to explain that without getting too deep. It just means that the thing on the right, if there's another way to change it without an equal sign, you can. So we can do myArray dot, we can shift and get rid of the first element, and it will get rid of the 1. So we can change what's inside, we just can't change what the variable is actually assigned to. Constant is fantastic because it will allow you to troubleshoot so much easier than tracing vars back after vars back after vars back. The constant is not truly immutable, as you can see here, but it will help protect you whenever from a lot of headaches. So these are our first 2 wins. We've looked at a bunch of different languages here, how different languages do things, and again, hopefully put things in perspective. We won't do this very often because it strings out the lesson, but it will help you hopefully going forward if you want to look at the other methods and the other things that we're talking about and compare them. Hopefully you'll feel a little bit more confidence to do it because you've seen it before. But in general, we're going to try and use let and const instead of var just to get used to writing them. Let is what you should be using anytime a variable is going to change, and const is what you should be using anytime a variable shouldn't change. And then if you decide later on it needs to change, you can change it to let. So we have block level variables. They can be function or even global block variables. And we have constants. So great update. It gets us closer to the world of C, Java, and C#. You can still go the PHP and Python route if you wish by using var, but it's always tricky because hoisting is such a kooky thing to deal with. So great work. We'll move on to another easy win.